There are two types of variables. They can be global and local. Variables can only reach the area in which they are defined, which is called scope. Think of it as the area of code where variables can be used. Python supports both global and local variables. By default, all variables declared in a function are local. To access a global variable inside a function, it's required to define it before. Local variables can only be reached in their scope. The example has two local variables, x and y. The variable x and y can only be used inside the function sum. They don't exist outside of the function. Local variables cannot be used outside of their scope. This line will not work. Does a function modify a variable defined outside it? There is a Python method which can extend a variable's scope in a way which includes the function's bodies. This can be achieved with a keyword named global. Using this keyword inside a function with the name forces Python to refrain from creating a new variable inside the function. The one accessible from outside will be used instead. In other words, this name becomes global. A global variable can be used anywhere in the code. In this example, we define a global variable z. The global variable z can be used anywhere, inside functions or outside. A global variable can be modified inside the function and change for the entire program. I modified a little bit the function seen before. After calling a function, the global variable is changed for the entire program. Okay, here I use a function to evaluate the three sides of a triangle. So, first of all, I ask the user to input three numbers corresponding to the three sides of the triangle. Then I define a function myTriangle with a, b, c, which are the three sides of a myTriangle. Then I compare the sum of two sides with the third one and make sure that the third side length is less than the sum of the two. Then I create the input field for the user. Finally, I check the inputted numbers and print the result accordingly. So the program evaluates the numbers and gives an answer. The answer can be yes, it can be a triangle, or sorry, it won't be a triangle. Okay, who's this man? He is Leonardo Fibonacci, an Italian mathematician, famous for his sequence of integer numbers. The sequence is one of the most famous formulas in mathematics. Have a look. Each number in the sequence is the sum of the two numbers that preceded it. The first element of the sequence is equal to 1. The second is also equal to 1. Every subsequent number is the sum of the two preceding numbers. Okay, now let's create our fib function and test it. Watch the next video clip. So here I implement the sequence as a function. The result should be a series of numbers where every subsequent number is the sum of the two preceding it. Okay, I start creating a function fib and checking if the first two numbers are less than 1 and 3 respectively. Pay attention here to for loop body and find out how I move the element1 and element2 variables through the subsequent Fibonacci numbers. Finally, I print the result of the function including numbers from 1 to 10. As you can see here, the result is exactly what we expected. Okay, remember, the code is available inside the Python file which you can download from this module. Use it for experimenting and testing. Before we start talking about tuples and dictionaries, we have to talk about two important concepts: sequence types and mutability. When we say sequence type, we mean a type of data in Python which can store more than one value, and these values can be sequentially browsed element by element. As the for loop is a tool especially created to iterate through sequences, this sequence is data which can be scanned by the for loop. You have met one Python sequence so far, the list. The list is a classic example of a Python sequence, although there are some other sequences worth mentioning, and I'm going to do it now. The second concept I'm going to talk is mutability. Mutability is a property of any of Python's data that can be freely changed during program execution. There are two kinds of Python data, mutable and immutable. Mutable data can be updated at any time. For example, the following instruction modifies the data directly in place. Immutable data cannot be modified in this way. Imagine that a list can only be assigned and read over. You will be able neither to append nor to remove any element from it. This means that appending an element to the end of the list will require the recreation of the list from scratch. You would have to build a completely new list consisting of the all elements of the already existing list plus the new element. The data type I want to tell you about now is a tuple. A tuple is an immutable sequence type. It can behave like a list, but it must not be modified in place. So what is tuple? The main difference between lists and tuples is the syntax used to create them. Tuples prefer to use parentheses, whereas lists like to see brackets. Although it's also possible to create a tuple just from a set of values separated by commas. Look at this example. There are two tuples, both containing 4 elements. Let's print them. This is what you should see in the console. Note, each tuple element may be of a different type, floating point, integer, or any other not as yet introduced kind of data. Let's see how to create a tuple. Is it possible to create an empty tuple? Well, you need to put parentheses like in this case. If you want to create a one-element tuple, you have to consider that the tuple has to be distinguishable from an ordinary single value, so you must end the value with a comma. Have a look here. Removing the commas won't spoil the program in any syntactical sense, but you will instead get 2 single variables, not tuples.